Everybody's favorite, fractions, right? Super important. We're going to multiply and divide them today. Fractions in lesson 22. Got some containers here for a gallon, quart, and a pint. We can use these measures to illustrate the multiplication of fractions. A quart is a fourth of a gallon, and a pint is a half of a quart. So what fraction of a gallon is a pint? If a pint is a half of a fourth, we multiply and find it's 1/8 of a gallon. Notice the numerator of 1/8 is the product of the numerators. And the denominator is the product of the denominators. It's not like add subtract where you don't put together the bottoms and they stay the same. You do work the bottom here. Notice 1/8 is less than both factors. So when you multiply fractions, you actually get smaller instead of bigger, because you're multiplying things that are worth less than 1. It changes everything. Normally, multiplying means you get a bigger number. But let's multiply 1/3 and 2/3. You can use these area models to help visualize. Maybe I could use a square here. Let's cut into thirds. If I multiply 1/3 and 2/3, just looking at how they use this. Yeah, we'll see what they do on the next page. I just go 1/3 times 2/3 is 1 times 2 is 2. 3 times 3 is 9, 2/9. I guess an area model could show us why is it smaller than when we started. That's what they use. I just multiply across the top and across the bottom. Remember how to cancel? We can reduce before we multiply. 8 divided by 4 is 2. 4 divided by 4 is 1. It's like we just reduced this fraction, but diagonally. It makes the numbers smaller so that we can do things mentally and we can not have to reduce at the end. It's great. So now we're just doing 3 times 2 and 1 times 3, which is much easier. Or no, this should say 1. I think they made a mistake in my book. That should have been 1 because we divided both by 3. So that should be 1, no, yeah, 2 times 1 is 2 over 3. Why do you think it's useful to reduce before we multiply? Because it's a lot easier to reduce 4 and 8 than when you multiply and you get huge numbers that are a lot more work. Remember, a reciprocal is the upside down version of a number. We use it when we divide. If we use it times its original, you always go back to 1, right? So you're flipping it over. You can show it like this too, or the reciprocal of 4/3, you can go like this. The reciprocal is 3/4. It's called inverting a fraction to form its reciprocal, or you could call a reciprocal its multiplicative inverse. So what's the reciprocal of 5/6? It'd be 6/5. What's the multiplicative inverse of 3? Same thing. It means the same as reciprocal. Remember, 3 is really 3 over 1. So its reciprocal is 1/3. Now, this throws some people sometimes. It's a reciprocal question. How many 1/4 are in 1? There's 4 1/4 in 1. Because 1/4 times 4 comes to exactly 1. How many 2/3 are in 1, though? You don't just say 1. You have to use the reciprocal. The answer is 3 seconds, because that's going to be 1 exactly. It's weird to count in 3 halves. 3 halves of 2/3. But it is the most exact answer, and it's what you're going to need to get it right in the book. We use reciprocals to help us divide fractions, right? Instead of dividing, we multiply by the multiplicative inverse. So 3/4 divided by 1/3. Before you do anything, you gotta multiply instead by the reciprocal. Can I cancel? No. So 3 times 3 is 9. Hopefully this is review and you're feeling good. Let's do B, D, E, and this whole section here, because you're going to get it in the book, so you might as well know how to do it now. Well, we better do divide too. So do this section, do B, D, E, and I guess pick one of these. I don't really care which one you choose. Just do it well. Thank you, thank you.